Hey everyone, welcome to another Calculus 1 video. Today we are going to talk about tangent lines and velocity. So for those of you in my class, we're doing this a little bit out of order. We focus all on all the derivative rules and don't spend as much time on the applications. Our textbook kind of picks that up in the middle, and so we're going back and touching on section 3.6. We're going to touch on section 4.6 as well in this section, but it'll be in a different video, and those kind of go together. And so we're going to talk about the tangent line. So if you remember, the original definition for f prime of x came from this limit thingy, the limit definition, if you remember correctly. And what did this limit come from? This limit came from, among other things, a formula called the difference quotient, which is the formula for the slope of a secant line. And a secant line connects two dots on a curve. When you take the limit as h goes to 0, that narrows it down to one line, and so this ends up giving us the slope formula for the tangent line. And that's the way that we developed this limit definition for the derivative. That was the very beginning of chapter 3. After that, we went and played around with a whole bunch of derivative rules, so we did not have to do the limit definition. And we don't have to do the limit definition still, but don't forget what it means. It means the slope of the tangent line, okay? So I'm going to wipe that out, and we're going to do example number 1 here. Okay, so how do we find the tangent line? Well, to find the tangent line, you need two things. To find any line, you need two things. You need a slope and a point. Okay, so how are we going to find the slope? The slope we find by taking the derivative. The derivative of this function is 12x cubed minus 12x squared plus 2 minus 0. Right? And then if you want to find it at 1, then you plug in 1 everywhere. So you get 12 times 1 cubed minus 12 times 1 squared plus 2, and you get 2. So the slope of our line is 2. What about the point? Well, if x is equal to 1, how do we find the y value for x equal to 1? Well, you plug 1 into the original function. So right away you're seeing it matters where you plug things in. That's why I have been harping on you guys to make sure you label everything properly. When you plug into f prime, you get the slope of the tangent line. When you plug into f, you get the point at which the tangent line passes through. And so if I plug a 1 in here, I get 3 times 1 to the 4th minus 4 times 1 cubed plus 2 times 1 minus 5. And if I evaluate that all the way out, I get negative 4. So my point is 1, negative 4. My slope is 2. And now, so this is step 1, this is step 2 if we need it. Sometimes this is given, sometimes it's not. And then step 3 is to write out the equation of a line. How do we do the equation for a line? Well, there's a couple ways to do it. You can do y equals mx plus b, or you can do y minus y1 equals m times x minus x1, called the point slope formula. And so we get y minus negative 4 equals 2 times x minus 1. And so you can either leave it like this, y plus 4 equals 2 times x minus 1, or you can solve it for y, distribute the 2, and get 2x minus 2 minus 4 is negative 6. Okay, so I'll take this equation and I'll take this equation. Okay, either one, point slope form or y-intercept form. I'm good with either form, and that's the solution. Okay, so what does this look like? Let me give you a picture of what's going on here. The red graph is your curve, 3x to the 4th minus 4x cubed plus 2x minus 5, y equals. And then your tangent line's y equals 2x minus 6, and see what's happening here. You intersect exactly at one point. Your line touches this curve at that one point, and that is the direction that your function is moving at that one point, is a slope of 2. And so that's kind of what's going on. We're looking for the blue line given the red line and a point. Obviously, if you change the point, you'll change the tangent line. Okay? So I want you guys to try one now. Pause the video and see if you can find the equation for the tangent line to the curve y equals x e to the 2x plus 2. Derivative's a little bit more complicated here. And the point you're given is x equal to negative 1 this time. So remember what you did, pause the video, go back if you have to, and try this problem. I'll see you in a minute. Okay, step 1. Let's take the derivative. F prime of x, this is a product rule, so I get the derivative of the first, which is 1 times the second, plus the first times the derivative of the second. The derivative of e to the stuff is e to the stuff times the derivative of the stuff. The derivative of 2x plus 2 is just 2. And so we don't have to simplify that at all because we just plug in the point -1 and we get e to the 2 times -1 plus 2 plus -1 e to the 2 times -1 plus 2 times 2. 2 times -1 plus 2 is 0, and e to the 0 is 1, and so we end up with 1 plus -2, and that's -1. So that's our slope for the tangent line, is -1. Okay? If you go to y equals for the point, you get y equals -1 e to the 2 -1 plus 2, which is -1 e to the 0, which is also -1. Okay, so we've got -1s galore here. The slope is -1, the point is -1, -1, and so to do this equation we get y minus -1, -1 times x minus -1, and so we get y plus 1 equals -1 x plus 1, or y equals minus x minus 2. Okay, so again, I'll take it in this form or in this form. I don't want two negatives in a row, but certainly slope-intercept form is a legitimate form. Okay, so that's how you do equations of a tangent line. The other thing in section 3.6 is talking about velocity, and so I need to give you a little bit of background here about velocity. Position is often represented by s of t, or if it's height, which is a position, right, then it's h of t, and both of those represent where you are. That's a position you're in. If you take the derivative of that, the derivative of position is velocity, because that's change of position, okay, velocity. And then if you take the derivative of velocity, what's the change of velocity? It's acceleration. Okay, so your second derivative of position is acceleration. So if we take a look at this problem, h of t models how high a bullet is that is fired straight up in the air. How long does it take the bullet to hit the ground? Well, that has nothing to do with calculus at all. That just has to do with h of t equals 0. When is h of t equal to 0? Okay, well, set this equal to 0 and use the quadratic formula. You might be able to factor it, I don't know, but I'm not going to try to factor stuff with decimals in it. Okay, so we need to use the quadratic formula here. I'm going to go to a separate page to do the quadratic formula because it is lengthy. So we get t equals minus b, 900, plus or minus the square root of 900 squared minus 4a c. A was negative 4.9, c was 2.4, and then we get over 2a. Remember what our units are here, meters per second. So this negative 4.9 and this 2.4, those are numbers that are in meters, okay, because we're in height room here. So t is going to give us the time, and so if we calculate this out on our calculator, we get negative 900 plus or minus, when I take this square root, I get 900.026, and then that's all over negative 9.8. And so when I add or subtract, I end up with negative 1800.026 over negative 9.8, and I also get positive 0.026 over negative 9.8. And so the time is equal to 184 seconds if I round to the nearest second. And this is 0 seconds, which is not exactly accurate, right? It's 0.01 seconds, but rounded off to the nearest second, it's that. So, and that's because you're just barely shooting it right above the ground, right? So this is the time it takes for it to come back down, 184 seconds. And so when we get t equals 184 seconds, what does that mean? We're not going to do the maximum and minimum velocities right now. We'll do those in chapter 4 and talk about that more. What's the velocity of the bullet after 60 seconds? How do I find the velocity? The velocity is found by taking the derivative of the position function. And so this, bring down the 2, you get negative 9.8 t plus 900. The velocity after 60 seconds then is plug in 60. Plug in 60 for t, you get negative 9.8 times 60 plus 900. Plug that into your calculator, and that tells you 312. What's the velocity is in meters per second, so that's meters per second. Remember, when you take the derivative, this is a dv dt, so, or a dh dt, excuse me. What direction is the bullet traveling at 60 seconds? Well, positive velocity means up. If that were a negative number, it would be down. Okay? So that's the way some of those problems work. You've got a worksheet that has many problems to play around with on velocity and also with the tangent lines. Check those out. And as always, reach out if you have any questions. Thanks.